Welcome, everyone. I can't see you, so I hope you're here. My name is Dr. Tyler Bland, and I am a professor at the University of Idaho in their medical school. What this department is, this is the WWAMI department. So if those of you who aren't familiar, WWAMI stands for Washington, Wyoming, Alaska, Montana, Idaho. And what it is the UW School of Medicine. Their medical students can take their preclinical years, so the first 2 years, in one of those sites. So we are the I in WWAMI. I teach mostly the pharmacology curriculum at our school for first and second year medical students. And I know I'm biased, but pharmacologists kind of need to know a little bit about everything. They kind of need to know how healthy works and how diseases work in order to layer the drugs on. And so because of that, I try to develop ways not only to help my students learn and remember the material, but to help myself remember it as well. And so with that, let's go ahead and get into one of the ways that I'm trying to do this. All right, so I hope you all can see the slides. Also, we are going to save questions for the very end, but if you have it, go ahead and throw them in the chat, and I'll go ahead and take a look at those after the presentation's over. I'm hoping to end a little bit early so we can get to some more questions. So my talk is, what if Pokemon went to medical school, here at the Stanford Innovate Ed 2024. So let's get into it. So what we're going to be doing today is I'm going to be introducing our game, which is called Medimon, where we are blending medical education with monster taming mechanics, which is the type of genre that Pokemon is in. I'll demonstrate to you how it's able to do this, how we're able to simplify some of these complex and sometimes abstract medical ideas into something a little more tangible and hopefully more fun for students to play around with and learn. And then at the very end, we'll look briefly at what are some of the benefits of game-based learning and using this type of education in the classroom. So I hope everybody is familiar with Pokemon. But if you are not, Pokemon is a monster taming game. What this is players can travel around the world. They can catch these monsters. They can level them up. Pokemon's motto is "Gotta catch them all," because one of the ways that players play this game is through collection. Is they have a certain number of monsters in the game, and you try to get all of them, either through catching them or through leveling them up. Most people are familiar with Pokemon Go. This is the mobile game on the phone where people walk around into the street and off cliffs and stuff like that. We are more reminiscent of the earlier years of Pokemon, where it's more on the computer and it's top down and you travel around and catch these, which you'll see here in a sec. But what I was trying to do is develop a Pokemon game. And what if this Pokemon game made you smart? And so thus birthed my game, Medimon. And so for those who aren't familiar, Pokemon is short for pocket monsters because you keep them in the little Pokeballs and you keep them in your pocket. Medimon is short for medical monsters. And so in Medimon, we have over 180 different monsters that represent various aspects of the body, both healthy and diseased. We even have pharmacology, of course, because I teach pharm. I have to put pharm in there. We have some nutrition, some biochemistry. We kind of try to dabble in all the different basic science areas to help students understand and give them a fun way to learn this material. And so I'll get into an example here. And so similar to Pokemon, where Pokemon, as you level up and evolve your Pokemon, they usually start out as a baby and then they evolve into an adolescent and then eventually into an adult stage. We have the same thing in Medimon. And so in Medimon, we have a baby stage, an adolescent stage, and then an adult stage. And this is the bone family. And so the different stages on the right here, the baby is osteoclast, the adolescent is osteoblast with a B, and then adult is skeleton. And so what we've tried to do is pick a body system as the overall family and as the final stage, and then pick either cell types or subdivisions that are part of that system as the baby and the adolescent stage. Now, on the right here, we have the healthy versions. We also have diseased versions of all of these over here on the left. And so disease osteoclast, this is osteoporosis. Disease osteoblast is postmenopausal osteoporosis. And then disease skeleton is Paget disease. Now, what sets us apart here is that each of these characters teach you about the real world item that they represent. And so here we have we're going to continue our example of the bone family. And we can see here in the osteoclast where the osteoclasts in the cell break bone down. And so he is breaking a bone. We have a little C necklace for clast. And its little Red Riding Hood cape. This is the actual morphology of these cells. And so if you look at these cells under a microscope, they're very large. They have multiple nuclei and they have this ruffled border. And so we've added that into the cloak here, where we have this ruffled border of the cloak, ruffled border at the bottom, and then these multiple dots here representing multiple nuclei. On the osteoblast side, he has a bone hammer and it's full because blasts build up bone. He also has a construction hat for building and a B for blast. Osteoblasts also secrete a molecule called rankle to activate osteoclast. We've represented that in the cloak as wrinkles. So he has a rankled cloak. I realize this one's a bit of a stretch. They're not all winners. But you can see here how we're taking a lot of this information about various cell types, various physiological functions, and baked them into the designs of these characters. And so we hope that students can use these as mnemonics to remember these important characteristics. And so if we go into the disease versions here, so this is diseased osteoclast, which is osteoporosis. So he's big and strong because your osteoclasts are chewing up too much bone in osteoporosis. He's also eating bone. These bones are fractured because you are at increased risk of bone fracture in this disease. He's absorbing bone, and then he has a cane because this largely occurs in the elderly. For postmenopausal osteoporosis, similar things, except one of the important parts in postmenopausal osteoporosis is this is largely due to low estrogen levels. And so she's spilling estrogen here. We don't stop with the mnemonics just at the character designs. We also build them into their battle moves. And so similar to Pokemon, you battle Pokemon, excuse me, to level them up, to increase their stages and increase their strength. Same thing in Medimon, except for all of our moves, I should say most of our moves, help students, again, further learn kind of these important aspects. And so these are the osteoclast moves, where it has cell strike. So these are cells. They secrete hormones. They lead to bone degradation. During bone degradation, this is one way that the body can mobilize calcium. And so we have calcium stampede. I should say that we represent calcium in Medimon as cows and milk. I originally meant this to be there's calcium in milk. And then one of my students thought that it meant I was saying calcium for cows, and it stuck. And so we have calcium stampede. And then these cells also release acid in order to help degrade bone, which is similar to the way parietal cells secrete acid in the stomach. And so we're able to further link these different physiological functions between different cells here in the moves. And so acid gush is performed by osteoclast. It'll also be performed by parietal cell, the Medimon, in the stomach family. We take it a step further and we add mnemonics to the world itself. And so each family has a specific location in the game and a specific building. And so the bone family's building is Skeleton Crew Framing. You can see down here. This is a hardware store like a Home Depot. The reason why we picked Skeleton Crew Framing is that bones give your body the framing. It allows your muscles to work and gives your body shape. If you walk inside of the building, we've added the different types of bones. So long bones, short bones, flat bones, irregular bones, where players will be able to interact with each of these areas, and a little text box will pop up and reveal some important information about it. Again, furthering the learning. One cross relationship between our Medimon. You can see up here in the tendon. So this is actually the muscle Medimon. He has these braids, which is kinked at the end with a bone in the shape of a T to help remember that tendons connect bones or muscles to bone. And then down here we have the ligaments where we have links connecting bones for ligaments to represent ligaments connect bone to bone. So if we can go ahead and see an example of this in action, this is a short video of the game where you are the player here, and then we'll go ahead and play it. And so you can travel around this world, you can go into buildings, you can interact with various NPCs that will either teach you something or you can battle them in order to level up your characters. You can go out into the tall grass where you can interact with wild Medimon. And so here's an example of a battle scene here. I'm going to go ahead and pause it. We can look at the different stats that we have. And so down here you have, these are hit points. This is your health. Each move requires energy to perform, and this is through ATP because ATP is the fuel source of the cell. And then we also have a stress mechanism. And so as you perform moves, your stress goes up. And then once you get into the red zone, healthy cells, or I should say healthy Medimon, run the risk of evolving into their disease state. And then diseased Medimon run the risk of self-destructing. Again, kind of further iterating, stress is not good. And so let's go ahead and play through this. So these are the moves that this Medimon knows. You can click on the information to help explain a little bit more about what that move does or why it knows it. And you can click on all these to be able to learn these different aspects. We also have various items in the game, and so I'll pause it here real quick. We have different macromolecules, so carbohydrates, proteins, fats. These will give you ATP and in ascending order. So proteins give you the smallest, and then carbohydrates, and then fats. Again, to kind of reiterate that amino acid breakdown gives you some energy, carbohydrate breakdown gives you more, and then beta oxidation of fats gives you the most. We also have health items. And so what we've tried to do is reiterate some nutritional facts on fruits and veggies, and some of these superfoods are healthy, as well as some of those macromolecules can give you energy. And so here we'll give our osteoclast an apple, and this will increase our health. And then again, one of the main aspects of Pokemon is gotta catch them all. And so we have a similar mechanism in Medimon, but instead of Pokeballs, we have Mediboxes. And these are organ storage coolers because you're storing cells and organs in these. This is how you catch them. All right, so we'll go ahead and catch this guy. So you throw your Medibox out. And we have a successful catch. And so now this Osteoclast is now added to your party. Inside of the menu, all of these mnemonics are labeled, and so students can go here to learn about what they represent, as well as a short description of what this cell type, organ, or disease does. On the gaming side, as we scroll down, we'll see they have, oh, here's the different evolutions. They have multiple stats, and so we have the HP, ATP, and stress, which you just saw, but then they also have an attack and defense stat, and then also a speed stat. And then all of the moves here that you can see. All right, then we can continue. And so basically what we're trying to do is take this, a lot of times students are given textbooks, long syllabi, course packs, which are just packed full of text, and convert that into not only an easier to remember format, but also hopefully a more enjoyable format. There was also difficulty in designing these different monsters. And so this is the blood family up here, where we have red blood cell, platelet, and clot. We ran into the problem of how do we get these to look like they're in a family together, but we also had to take it a step farther in that many of these medis are in other families. And so if we look, red blood cell is down here in the lung family, so alveoli. In the vasculature, this is capillary and artery. We had to make sure that they fit well in different families. For platelet, we had to make sure he fit into liver. And then for clot, fit into deep vein thrombosis, cirrhosis, and nosebleed. And so again, we had to have consistency inside of a family as well as consistency across different families. There are a lot of benefits of game-based learning. There's many research articles out there. This is just one review that brought a lot of them together, but it's been shown to increase engagement, test results, knowledge, short, long-term retention, accessibility. Also, it's fun. A lot of times students prefer the game-based learning as opposed to reading a textbook chapter. And then I also wanted to clarify the different aspects of game-based learning. And so we have serious games. Oh, I'm missing a bullet here. Gamification and simulations. What the difference is here, because sometimes these get interchanged inappropriately. Serious games are games that are designed for education. So this is a full-fledged game that you can play on its own, and its main purpose is to educate. And so Medimon could be classified as a serious game because we are trying to teach about medical information, and it is a standalone game. Whereas gamification utilizes game resources in education. And so this isn't a full-fledged game. This is where you pull different aspects of games and use them, say, in a lecture or in a worksheet or in some sort of activity in class. And then a simulation kind of is self-explanatory. It simulates something in the real world, but it gives you a safe environment to learn it. And then gamification could be added into a simulation. So for instance, if you're practicing doing catheterization and you get points for how well you do that, the act of mimicking the simulation is the act of mimicking the catheterization is a simulation, and then adding on points to how well you do it is a form of gamification. You can play our first level. That's as much as we have done here. And so you're welcome to do that. If you go to our website, medimon.games, you can see all of our characters, all of the different mnemonics, and then you can go ahead and find the demo link there. Please download it, give it a try. There's a survey in it. Let us know if you find any bugs or if you have any ideas. We're always all ears. We love to hear what people think about it. All right, and so with that, I will go ahead and answer some questions. And so I see we have a few in the chat here. What is the age range for players? That's a great question. Our age range, I'm not allowed to say this, but I say everyone, but they tell me I can't. And so I built this for our medical students so they will get the most out of it. My 6-year-old daughter loves this. Does she understand the medical aspects of it? No. Does she understand the mnemonics? No. But you can play this purely on an aesthetic basis, purely as a Pokemon game, and still get something out of it. So we're doing stealth learning here. What I hope for younger individuals that play this game, that they don't understand the medical aspects, is that what we're doing is we're laying the foundation of future learning. And so my daughter knows what the name osteoclast is. She knows what it looks like. She doesn't know what it does or what all those mnemonics means. But what I hope is that in the future, when she gets to high school or maybe undergrad, when she goes into a class where she learns bone physiology, it's much easier for her. Again, because I've laid that foundation of she knows the name and she knows what it looks like. Now she'll fully understand what those different mnemonics mean. And so just to reiterate, all age ranges can play this. I would say probably maybe high school-ish to more college and above will get the full learning aspect out of this. When it says why moves aren't very effective and then they require to click, why they aren't very effective. Oh, okay. So why some moves aren't very effective. In Pokemon, they have kind of the rock, paper, scissors triangle, where rock is strong to scissors, which is strong to paper, which is strong to rock. We have the similar thing in Medimon, where certain types are strong to others. And so what we were looking there, let's see, that was a normal type move for Cell Strike, which was attacking a structure Medimon, which was the Osteoclast. And so normal is weak to structure. A lot of those strengths and weaknesses kind of make sense. So, for instance, brain is strong to the immune system because of the blood-brain barrier, but they don't always have a physiological function. Good question. What knowledge should the learner have before attempting to play this game? You will be able to learn or play the game easier if you have a background in previously playing a monster taming game or in the monster taming genre. That was actually one of the things we learned with our first demo is not everybody has played these games before. And so I actually watched my wife play it. She didn't know I was watching our very first demo. And I just watched her get angry at the computer. Like she didn't know how to do what we wanted her to do. And it wasn't her problem, it was my problem. I am too close to this, and so I just assumed that people would know how this game works, how you battle, what all the stats mean, how you catch medis. And so that was very, very useful for us. And so in the current demo, if you go and play it, we actually now start off with a tutorial, which teaches you what each of the stats are, how to battle, how to catch, how to heal, and how to save the game. And so we walk through players who have no experience with this, how to do each of it. So you shouldn't need to have any sort of background knowledge in order to play this. Have you assessed the efficacy of learning the content this way versus traditional learning? We have not tested the ability of this to increase knowledge, the game yet. And the reason for that is we just released the demo last week. And so this is very fresh. We have integrated the characters into our lectures. And so when we talk about when we talk about granulocytes, for instance, we're able to integrate the granulocyte medis into those lectures and then have the labeled mnemonics in there. And so it's not necessarily the game that they're using, but parts of the game. So this would kind of be classified gamification. We don't have solid data yet, but students have said they preferred using this to learn, have said it is useful. We've looked a little bit at exam scores on students who have used it and haven't, and it's kind of a mixed bag. But again, this is just enhancing lectures and not actually playing the game, which you're very welcome to do. That's kind of the lowest common denominator. If you want to use this, you can get all of our images from the website. You can download them, integrate them into your game or into your lectures. And then once we get a functional game, then we'll start testing efficacy, how well it teaches students. Do you have thoughts on what medical topics are appropriate for gamification and which are not? We haven't necessarily gone into what medical topics are appropriate or not. We've more looked at age ranges. And so I originally wanted to test this in pediatrics, and I talked to a couple peds docs, and they actually recommended I don't do that, especially at younger ages, just because kids at that age might think that there's an actual monster inside of them and not understand that it is representing a disease that they may have or an organ system that they have. This is cool. Definitely check out and wishlist on Steam. Yes, so please wishlist this on Steam. It helps with the algorithm. If anything, that would be super helpful. And then again, play the demo. There is a survey in the demo, and so please fill that out. Let us know what you think. And again, if you find any bugs, let us know. And so with that, I am on time. If you would like to reach out to me at all, you can find me online or at our website. So thank you very much for attending.